In this video, we're going to extend some of the ideas we did last time. So with that said, let me do an example here. Online, I found a 113 gram jar of beluga caviar. So this was a Russian one. It was 7,100 RUB, 7,100 rubles. That was an online price. Now, that I found that was on a Russian website, I believe. Now, I looked also on America. So in America, I can get an 8-ounce can for $149. Which of these two is the better price? So basically, I don't know how 8 ounces compares to 113 grams. So what we're going to do is take a look. We're going to take 7,100 rubles and divide it by 113 grams. And what I want to do is convert this to American dollars to ounces, since the thing I just bought is in dollars and ounces. So first, let's start with rubles. So as before, I'm going to go online for that. Let's pop into the internet. So I'm going to convert a ruble to US dollars. So let's find out what today's exchange rate is. Let's see, rubles to USD. That looks like a good one to use. I'm going to try the other way. I don't like these decimals like that. So I'm going to do USD to ruble. I see it second in the list. I like this much better. So $1 equals 100.7 Russian rubles. So let's put it over here. $1. Now let me go ahead and what I'll do here is remember, if I take and divide by 100.7 rub on both sides of this, then when I multiply, so this will equal 1. When I multiply by 1, I'm going to do it in the sneaky way where I'm going to do $1 divided by 100.7 rub. This way those cancel, and let me see what my new number is. So basically, I'm going to take 7,100 and first divide by 113. 7,100 divided by 113. I get 62.83 so far, and then I'm going to divide again by 100.7. And it looks like I'm going to get 0.6. I'm going to take several decimal places here, so 0.62395. I'll use several places here because at the end I want to be able to report this. So this is in terms of dollars up here, but then we have per gram. All right, now I need it in order, I still need to get myself to ounces. So let me find grams versus ounces. Grams to ounces. 1 ounce, I don't like it. I always ask the exact reverse of what I want. Ounces to grams. Let's try that one. All right, so 28.3495 grams. And that equals 1 ounce. So what I'm going to take is this information, my 0.62395 divided by 1 gram. I'm going to multiply it. Now, once again, I want the grams to be on top. So I'll put my 28.3495 grams up there and divide it by 1 ounce. That way these grams cancel, and let me see how much I've got in terms of per ounce. So let me go back to my calculator. We're going to go, so there's the number I had before, and it looks like I'm just going to multiply by 28.3495. So times 28.3945, and that gives me, I'm going to go to 2 decimal places here because we're now at a cost. That gives me $17.72 an ounce. Now, to figure out our total cost for this particular thing, I need 8 ounces of this. So 8 ounces. So I'm going to take my 17.72 divided by 1 ounce, and I'm going to multiply it by 8 ounces. This way the ounces will cancel out and it will be left in terms of cash. Let me pull up the calculator again. So we're going to take our 17.72 and I'm going to multiply it by 8. 141.76 is my price. So let's compare the Russian version of it. Came out to 140, this is the Russian price, 141.76. In America, I can get an 8-ounce can for 149, and in Russia, I can get it cheaper. Only one problem here. They do got to ship it to me from Russia. Now, if this were the price of a specialty store that I were shopping at, a store maybe that specialized in Russian food and other foreign foods, but if we scroll here, but chances are I'll have to get it sent to me, and shipping is going to crush me. So most likely this American price that I'm getting is going to end up being better than what I'm going to be paying here. Unless, of course, I'm having both of them shipped, then I have to do a comparison. Recently, I looked up the gas prices in Canada, and this is what I found for the cost per liter of gasoline. 1.51 CAD per liter. This is Canadian gas. So what I would like to do is convert that to dollars per gallon. So I have to convert everything here. Let's start with the CAD part. So I'll convert from Canadian dollars to American dollars. So let's try USD to CAD. There it is. So an American dollar is 1.43 Canadian dollars. So let's put it over here. So 1 US dollar is worth 1.43 Canadian dollars. So let's start with 1.51 CAD divided by L. I'm going to multiply by 1, but I'm going to do it in this sneaky way. I want dollars on top, but I want CAD on the bottom so that I could cancel it out. Cancel the CADs. Now, if I want, I could do this right now and get myself a new answer. I'll take the 1.51 divided by 1.43. And I get 12.09144. 12.09144, and that is dollars per liter. Now we're going to need to change liters to gallons. So let's go and look that one up. Apparently I want to end up in gallons, so let's do gal to liters. There, I don't even have to type in much for that. 1 gallon is 3.78541. 3.78541. 3.78541. That's how many liters are in 1 gallon. So we're going to take this. Now this time I want to put the liters in the top because I want to cancel it out. So I'll put my 3.78541 liters up here, cancel them already, and down below I'll put gallons. So this will give us the American price. So this is just to multiply this out. I can see there's an error here. Look at this. 1.51 divided by 1.43 really shouldn't be much more than 1. What happened with my calculation here? Let's check it out. Let me do it again. It's not there that I can tell. How did I get this? Times 8. 1.5. I don't know exactly what I was doing. Let me do the calculation again. It is supposed to be 1.51 divided by 1.43. All right, this is a little bit better. I'll say 1.0559. So let me erase this. So I think that'll be enough decimal places. And now let's go ahead and do the multiplication and find out what the American version of this is. So I'll move this past. Oh, I already got it there. So then I'll go times 3.785. And since this we're talking about dollars and cents, this is $3.99. Really about, if you round, this is really $4. $4 per gallon. How long does light travel in a nanosecond? So let me go and pull up the speed of light, which we've already have from before. We looked it up before, so I'll write it down. So it's that many meters per second. What is a nanosecond? Well, I don't know. I need to convert nanoseconds. So let's have nanoseconds to seconds. Let's see how many that is. So come in here. I need to wipe out the seconds. So let's do seconds to nanoseconds. You can see it's already there, nanoseconds. 1 times 10 to the 9th. So we have 10 to the 9th equals 1 second. So this just means that there's a billion nanoseconds per second. In other words, there's 9 zeros total if you were to write this out. So what we're going to do then is we're going to multiply. Since I want to get rid of seconds, I'm going to put 1 second on the top, but in the denominator, I'm going to put 10 to the 9th nanoseconds. And so the seconds will cancel out, and now I need to do this conversion here. So it basically is going to be this number divided by the 10 to the 9th. Let me grab the calculator. Let's start again with my speed of light. So we have 299,792,458. And we want to divide by 10. Now I got to raise it to the 9th power. So it's about, I would say if I rounded it, rounding it to 0.3 seems completely reasonable here. Look at all these digits. That'll be good to 5 decimal places accuracy. So we'll call it 0.3. So we have, it travels in a nanosecond 0.3 meters. How long is that in inches? So we want to convert meters to inches. Let's go ahead and find the computation for that. So here, 1 meter is 39.3701 inches. So let's start with our 0.3 meters. Now I want meters to occur on the bottom since I want to cancel it out. We want the meters in the denominator so that they cancel out. Here I just have 1 meter. That means we put the inches in the top, 39.3701 IN. And let our calculator do the job. 39.3701 times 0.3. We have 11.811 inches. That's how far light travels in 1 nanosecond. The square footage, what do we have? Square miles. Ohio has an area of approximately 44,825 square miles. How many acres is that? So the easiest thing to do is we can maybe get a connection between miles squared and acres since they're both measurements of area. So let's go on the internet and try to do, let's try acres to square miles. And I don't like that. I prefer, let's do square miles to acres. 1 square mile is 640 acres. This is by definition. I like this much better. So 1 square mile is 640 acres. So 1 square mile is 640 ACRE. And so let's take our 44,825 square miles. Now I want the square miles to appear in the denominator so that I can cancel them. So see how those cancel? And then put the 640 up top and let the calculator finish the problem out. 640, I'm mixing though, ACRE. Make sure you get your units in. 44,825 times 640, and we get 28,688,000. And this is acres. For temperature, we have 3 different systems of measurement. And what we're going to be doing is looking at some important temperatures. We have water, freeze. And what I'm going to do is we're going to keep track in Fahrenheit, which we'll use the letter F for that one. Celsius, we'll use the letter C for that one. And then Kelvin, This is a specialized measurement that scientists mostly use. It's certainly not used normally by any humans that I know of. Now for Fahrenheit, water freezes at 32 degrees. Celsius, however, it does it at 0 degrees Celsius. Kelvin does it at 273.15. Notice they don't use a little degree symbol. Now let's look at water boil. For Fahrenheit, that's 212 degrees. For Celsius, it's 100 degrees Celsius. And for Kelvin, it's 373.15 K. Notice how the Celsius is a lot, probably nicer, just because it seems more reasonable to choose 0 at the temperature when something freezes and 100 when it boils. Americans, we had our limits, of course, much earlier than Celsius came around, at least in America. But let me look at the Celsius to Fahrenheit conversion first. And what I'm going to do is I'm going to draw a picture, just a rough sketch. And I'm going to put Celsius on the horizontal axis and Fahrenheit on the y-axis. And I'm going to try to develop a scale between them. So if you'll notice, when we had freezing water, if we looked at an ordered pair, Celsius first and then Fahrenheit second, when we looked at freezing, the Celsius was 0, but the Fahrenheit was 32. So if I were to graph these things, what I'm going to do is put 200 degrees up there. That means here is about 100. And then I'm not really that important. I'm just going to put over here the one that's at 32. Now we move all the way down this axis here, and I'm going to go to 100 degrees Celsius. According to boiling, if I look at the Celsius versus Fahrenheit, at boiling, Celsius is 100, but Fahrenheit is 212. So what you do here is I try to find 212 on the y-axis, and then I put a dot above here. So the x-axis, it was 100 degrees, and the y-axis is 212 degrees. And then what I'm going to do is connect with a straight line these two things. And you can extend the line, actually goes on forever, like so. And so I want to get an equation for this line. That means y equals mx plus b. We already have the b. That's where it crosses the y-axis. So b equals 32. The m is a little different. The m equals what's called rise over run. The rise here is how much it went up for the y values. It started at 32, but it ended at 212. So that's as far as it went, from 32 to 112. So we're going to do, or 212. 212 minus 32 there. The run, it's 100 minus 0. It looks like I lost my axis by, let's try it over here. In the run part, we're going to have 100 minus 0. Or it'll end up being 1.8 after you do all this. So that's the m. So my y equals 1.8 x plus 32. Now if I put down the letters that I want, f equals 1.8 c plus 32, this formula will convert Celsius to Fahrenheit. Convert 40 degrees Celsius to degrees Fahrenheit. The Fahrenheit will equal 1.8 times 40 plus 32. So we're going to have 72 plus 32 equals 104 degrees Fahrenheit. So 40 degrees, while it sounds cold, if it's in centigrade, it's pretty warm. Now another one that I like to do is convert negative 40 degrees Celsius to degrees Fahrenheit. Same formula, F. This time we'll have 1.8 times negative 40 plus 32. So I have negative 72 plus 32 equals negative 40 degrees Celsius. In fact, this is the only temperature in the world where Fahrenheit and Celsius agree. Negative 40 degrees Fahrenheit happens to equal negative 40 degrees Celsius. A certain drug is dosed (200 milligrams) per kilogram of weight. Per day. Chet is receiving this dose, and he weighs 75 pounds. How much of the drug does Chet get every 8 hours? All right, the dose goes like this: 200 milligrams per kilogram. Unfortunately, Chet is measured in pounds, so the first thing I need to do is change pounds to kilograms, or kilograms to pounds. The way I want this next thing, I'm going to work on his weight first. So I would like to get kilograms up here and then pounds in the denominator. So let's go ahead and do that. So whatever you put first is what it assigns to 1. So let's do kilograms to pounds. So 1 pound is 2.20462. 2.20462. 2.20462. That is LB equals 1 kg. So I want the LB to be on the bottom, so I'll put 2.20462 down there and put a 1 up there. This way the kilograms will disappear. Let's do that computation. So this is going to be 200 divided by 2.204. Let me see the last couple of digits. 62. It looks like this is going to be 90. Let's say 719. And that is milligrams per pound. In order to get the total amount of milligrams, I'm going to have to multiply by 75 pounds. Remember, this is per day. So then we're going to take our 90.719 milligrams per pound, and I'll multiply by 75 pounds. Let's let the machine do it again. So it looks like 6,803.925. So let's just do 6,804 milligrams every day. Now what they want is this to be for 8 hours. So to do this, so for 8 hours, this is per day. what we can do is divide it by 3 for 8 hours. We'll take our 6804 divided by 3, and what do we get? $2267, I'm just going to say 2268 milligrams every 8 hours. What is 2268 milligrams in ounces? And you may be able to do that all in one shot, but I prefer not to. I'm going to do ounces to milligrams. I'm going to do it the other way. I'm going to try OZ to milligram. That looks a little better. So 1 ounce is 28,349.5. 28,349. 28,349.5. So this is 1 ounce. Let me erase this. 1 ounce equals that many milligrams. So we're going to take our 2268 milligrams, and I'm going to want to put milligrams on the denominator so that they cancel. And I'll put 1 ounce up here. So let's cancel the milligrams and then see what we have. Let's just divide that by 349.5, and it looks like 0.08 of an ounce. And that looks like his daily dose in terms of ounces. The average consumption, let's say the average food, well, we'll just say the average consumption of an adult female is 2,000 calories per day. How many joules is that? Well, this is the interesting thing. Joules is a metric version of energy. Calorie is an American version of energy. We know the more calories you have, the more you have to burn to lose weight. That's why it's an energy, because you have to do work to dissipate it. So we have to convert calories a day to joules per day. This should be a one-shot deal, I'm thinking. Let's go into the computer and let's do joules to calories. 1 joule, I don't like the looks of that. I'm going to try the other way. Here we are. 1 calorie. Now this is interesting. You don't know this, but it says 1 kilocalorie. Technically speaking, the word cal that we use is scientifically equal to kilocalories. But we'll ignore that because that's not what we're going for right now. It says one of these calories, 1 cal, is equal to 4184 joules. So let me write that down. 1 cal equals 4184. And the international letter that's used for joules is the letter J. So let's start. 200,000 calories per day. And we want to change calories to joules. So I'll put the joules on the top and the calorie in the denominator. Cancel the calories, and this is just a multiplication problem. So I can do it in my head. 8368, and then I'll put 3 zeros at the end of it. and that is joules per day. Nora's LDL cholesterol measures 200 milligrams per deciliter. How much cholesterol is in Nora's body? Before I go one further, I made a mistake. I was not as specific as I should be. I should be asking you how much LDL cholesterol is in her body. Your body has more than just one type of cholesterol. The LDL is the one that they call the bad cholesterol because it stands for low density lipoprotein. The low density is the stuff that sticks into the insides of your arteries and whatnot. But anyways, we have 200 milligrams per day, per deciliter. So basically, we want to find out how many deciliters of blood you have, and then you'll know how much. So let's see if we can find, it might be better just to convert from deciliters to pound. Let's see here. Nora is probably going to be given weight in terms of pounds or ounces. So maybe we could do pounds and ounces is what we want to do. So let's first do, let's change the 200 milligrams. Let's change that to ounces. So let's do that. I think I just did it a second ago. (28349.5). So I put them in the right spot. Let's divide here. Now, one of the things you can do, I'm going to show you something here. Right now, I'm in ounces per deciliter. I would like to change the deciliter to pints. I think we know how many pints of blood people have. I'm usually told women have about 7 pints of blood. So maybe we can go deciliter to pints. Let's try that. So let's try pints to deciliters. So 1 pint is 4.73176. 73176. So that was deciliters per. This way the deciliters cancel out, and it looks like I'm going to have ounces in the numerator and pints in the denominator. So I'll have ounces per pint. Let me go ahead and do all these computations. So you can simply multiply all the top together. So I have 200 times 4.73176. That's 946.352. Now that is ounces in the top, and let's divide by this number here. I think that's the only thing in the denominator. Divide by 28349.5. It looks like 0.0334. I think there was 3 4s, 3 3s, and then a 4, and that would be, what do we have left then? Ounces per pint. Now, I'm told how many pints are in an average female. Let's take a look here. Let's see, we do pints of blood in an adult female body. The average adult female has about 9 pints, so we'll use that. So then we're going to take our 0.03334 ounces divided by pints. We're going to multiply it by 8 pints. That way the pints cancel out, and we'll get the total ounces that we have of cholesterol for this person. So we had our 0.3338. I put a 4 in there. Should have been an 8. Let me fix that. Not to matter, because I'm just going to take the number I have there and multiply it by 8. So I'll just do times 9, 9. And it looks like 0.300, so I'll just say 0.3 ounces. That's how much LDL cholesterol is in that person's body.